Good morning. All right, so I think I fixed the delay thing. I think I did it. I think this is really, really, really close to a live stream. And I think I can do better. So, who's all in the chat? Say hi, chat. I'm counting. No one's saying hi. Shalom. So, that was 10 seconds. That was 10. That was 10 seconds. That wasn't 30 seconds, which is much better. Good morning. Yes. So, I think I can do better. I adjusted some things. I switched some things around in YouTube. And I think that tomorrow's lesson is going to be even better, even closer to being live. My mic's working. Yep, everything's working. Everything's excellent. Okay. Are we doing okay? Is everyone still healthy? Is everyone getting things done, getting things together? At least I hope so. But here is, we're going to kind of recap 70-3. So in 70-3, we introduced the end behavior for a rational function. So basically, the end behavior is what is my graph doing as in all directions it's going to infinity. So in this instance, it's going to infinity here, here, I don't know if you guys can see it, down here, and right here. So those are 4 pieces of information that I'm going to describe what the end behavior is doing because it's going to do those 4 things. Going to this one right here, there is 1, 2, 3, 4, 5, and 6 different ways that my graph is going to infinity. And so what we do is we say, this is what my x is doing, and then we describe what my y is doing based upon what my x was doing. So in this instance here, for this first one, x was going to a negative infinity. Well, as when x is going to negative infinity, the number that it was approaching was 1. So I'm saying, as x goes to negative infinity, my y value goes to 1. Then it looks like right here is another important aspect, right? It's going to negative infinity down here. And so there's actually 2 directions. We can come from the negative side and we can come from the positive side. And so that's what this little minus or this plus here is going to reference. So in this instance, it's going to negative infinity from the negative side, because this is the negative side. And so it's going down forever, so that's why it's going to negative infinity. Now, as my that's my y value going to negative infinity, but the x is going to this value right here, which is -1. So as x goes to -1, boom, what is my y doing? Going down forever. Now from this side, same idea. So this is coming from the positive side. So as it goes to -1, from the positive side, what is my y doing? It's going up forever. And we do that for every single important aspect. It's one of those types of things where it's still a little vague until we start working with it, until we start visualizing a little bit more. So if there's still small elements of confusion, that's perfectly okay. That's normal. Let's go ahead and just get right into it. Now, I want us to be able to use Desmos for this, since I know that it says go ahead and graph these, but I have not talked about how to graph them yet. So that's okay. So we're just going to use Desmos for it. So for this first one right here, it says graph the following. So I'm going to pop this into Desmos. Okay, so this is my graph here. So it looks like this value right here is an asymptote. Now, you don't have to do this, but I'm just going to do it because it's going to make it a little easier for me to visualize. So I just type in x equals 2. And it looks like there's a horizontal asymptote. Let me zoom in a little bit more. Yeah, there's a horizontal asymptote at 1. And we could even look at our graph and even determine that, because in the last lesson, we compare the degrees. Well, the degrees are the same, so we divide the leading terms. X squared over x squared is 1. And so that's why my horizontal asymptote is 1. So let's start writing this out. I know that x is, we're going to start basically from left to right. We're going to describe what x is doing from left to right. Let me write this a little bigger here for you. And then let me squish this so I don't cover it. There we go. So the first thing I'm going to say is my x is going to negative infinity. So it's going to negative infinity here. And then moving along, then it's approaching this 2 here. So I'm going to say x is approaching 2 from the negative. So it's approaching it from this side. And then it's also approaching it from this side. So I'm going to say x is approaching 2 from the positive side. So it's approaching it from this side. And then what is my x doing here? It's going to positive infinity. So x is going to positive infinity. Now that I've established every little value that my x is doing, now it's much easier to say, okay, for each of those x's, what is my y doing? So for my x going to negative infinity, where is it going for y? Well, it's approaching 1. So I'm going to say y is going to 1. You could also say f of x. For it approaching 2 from the negative, it's going up forever. So I'm going to say my y is going to positive infinity. For it approaching 2 from the negative side, it's going down forever. My graph is going down. So I'm going to say my y goes to negative infinity. And then as it approaches and it goes towards here, I'm going to say y goes, whoops, y goes to 1. So as it's going on forever, it's approaching that value 1. You could do a rough sketch of it, just enough. So I don't need to see like exact accurate points. If I were to sketch this graph, my rough sketch would be 2, 1, and this. Like, that is sufficient for drawing the graph. Mainly because, like, just looking at that image there gives me all the information that I need to be able to do the end behavior. Okay, so any questions with that first part? Okay, let's look at another one. So we have x over 3x minus 6. Again, I have a vertical asymptote at 2, so that worked out. I'm going to make it dotted this time because it's annoying me that it's not dotted. For the vertical asymptote, horizontal asymptote, that looks like, ooh, that's weird, huh? Okay, so let's look at our graph. The degrees are the same. I have x to the first, and then this is x to the first, so we divide the leading terms. X over 3x, that should be 1 over 3. So that means that this horizontal asymptote, that's going to be 1/3. So I just need to be just aware of that it's going to be 1/3. And maybe I can draw that in. Y equals 1/3. And I'm going to make that dotted too. Yeah. See how it's approaching that number there? That just makes it a little easier for us to be able to visualize that. So just remember that that's going to be 1/3. So let's write out what all the important x's are doing. So my x is going to negative infinity. So I'm going to say x is going to negative infinity. And then I have x approaching 2 from the negative side. And then I have x approaching 2 from the positive side. And then I have x going to infinity. So those are the four important extremes on my graph. So now we have to state what y is doing. So in the first one, my y, so as x goes to negative infinity, it's approaching that y value of 1/3. So my y goes to 1/3. And then this is going down forever. So as x goes to x goes to 2 from the negative side, my y is going to negative infinity. And then as x goes to 2 from the positive side, my y is going to go to positive infinity. And then as x goes to infinity here, it's going to approach my y value of 1/3. Comments or questions on that one? If you guys don't know, look at this. It's such a hilarious cup. My wife got it for me. I don't need Google. My wife knows everything. Okay, so it seems like we don't have any questions on that. So let's look at the next one. So this one's x over x squared plus 1. X over x squared plus 1. And then it doesn't look like there's any vertical asymptotes here, just even looking at this graph. So I don't have to worry about that. But there is a horizontal asymptote. The denominator has a greater degree than the top, so I'm going to say y equals 0. So there's my horizontal asymptote. So writing this one out, it looks like my x is only going to the extreme, or there's only two extremes here. It's only going to negative infinity, and it's only going to positive infinity. So x is going to negative infinity, x is going to positive infinity, and then now we just state what is it going to be doing? Well, as x goes to negative infinity, it's approaching the y value of 0. So my y goes to 0. And then as x goes to positive infinity, it's again approaching that horizontal asymptote, so it's going to approach 0. And so that's my end behavior. Comments or questions on that? All right. Before we move on, I want you guys to take a look at 1, 3, 4, or 5. Are there any questions or any of those that you would like me to go over or talk about for those? Number 4? Maybe the delay isn't as bad, or is as bad. I don't know. You guys are probably taking a while to look at them. All right, so we have x to the third plus 2x squared plus x divided by x squared minus x minus 2. Oh, you're talking to your dad? Hi, Jazzy's dad. Okay. This one is definitely a goofy one. Let's try and identify this horizontal asymptote, though, because that'll help us a little bit. So x equals 2. Is that it? It looks like it. Yeah. There's the horizontal asymptote. Okay. So if you guys notice, there is no... Sorry, that was a vertical asymptote. There is no horizontal asymptote. And the main reason is because the degree on the top is larger than the bottom. And so when the degree on top is larger than the bottom, there is no horizontal asymptote. It is an oblique asymptote. And so there actually isn't any formalized way for us to say, well, how do we approach this number? If we just zoom out and look at this, it's just going to negative infinity. So there's actually only 2 directions that this can necessarily go. So I'm just going to zoom in just a little bit more. So the way that we would write this is we would say x goes to negative infinity because x is going to negative infinity, and we can describe what my y is doing as it's going and approaching negative infinity. Now x is also approaching this 2 because as we can see, that's going down forever and that's going up forever. So I can say x is approaching 2 from the negative. We're also going to have it approach 2 from the positive. So x is going to approach 2 from the positive. And then it's going to go on forever this way. So then x is going to infinity. So now we just need to describe what y is doing as it's doing that. So as my x goes to negative infinity, so my y is going down forever. So I can say my y is going to negative infinity. As x approaches 2 from the negative, that's going down forever. So then my y is going to go to negative infinity. As x approaches 2 from the positive, it's going up forever. So we're going to say it's going to go to positive infinity. And then as x goes to infinity, my y is going up forever. And so there is going to be the end behavior for that. So like I said, as x goes to negative infinity, it's going down forever, right? That's going down. As x approaches 2, it's going down forever. As x approaches 2, it's going up forever. As x approaches infinity, it's going up forever. Any other ones? Number 5. So we have x cubed. How's it going, Jackie? Over. Ooh, this is a good one. Okay, so let's zoom in. It looks like, and even verifying here, this is 1 minus x. So if I set that equal to 0, you're going to get x equals 1. So I'm going to have my vertical asymptote at 1. Again, because the degree, I'm doing good. I'm getting a little restless. I wish I could go outside more. I'm getting a little restless, but this is a good thing. We're helping people by staying home. So because my degree on top is larger than the bottom, I know that, yeah, I'm not used to the delay. I'm used to like a 30-second delay. Now it's like 10 seconds, which is better. Like I said, I think tomorrow it's going to be even closer. I think I figured it out. So since the degree on top is larger than the bottom, there is no horizontal asymptote. It's going to be an oblique asymptote, and that's why we get this goofy looking shape that's going on here, right? So we have all the information that we need, though. So let's start dictating all the different things that are happening. So as x goes to negative infinity, meaning it's going this way forever, I know that my y is going in a direction, so it looks like it's going to go down. But we'll do that in a bit. Then we know that this vertical asymptote, it's approaching that. So then this here, so as x approaches 1 from the negative, so x is going to go to 1 from the negative. And then it's going to approach 1 from the positive. So x approaches 1 from the positive. And then x can go on forever this way, and it looks like my y is going down forever as we're doing that. So I can say that x is going to positive infinity. So now just describing what the y is doing. So as x goes to negative infinity, my y is going down forever. So my y is going to negative infinity. As x goes to 1 from the negative, it's going up forever. So my y goes on to positive infinity. As x approaches 1 from the positive, it's going down forever. So that's going to be negative infinity. And then as my x goes to positive infinity forever, it's going down. So negative infinity. Any questions on that one? Now I know because the way that the lines are, it's a little weird here. Like it is, because it looks like it's still going at an angle. It's never going to curve downward. It's just decreasing its rate in which it's going down. Want me to do number 3? No, it's too late. Ha! We're already on number 5. Yeah, 5. Can't go back to number 3. Just kidding. Whoa. Delete. We have x plus 3 squared. Nice. Okay. My vertical asymptote, see where it says x plus 3, so my vertical asymptote is going to be negative 3. Because my degree is larger on the bottom, this will eventually become, because it says x plus 2 squared, this will eventually become x squared in the denominator. And that means that the numerator is a 1, denominator is a 2. So that means I have a horizontal asymptote at y equals 0. Clean that up a little bit. Whoops. go. So to talk about what's going on, so I know that x is going to approach negative infinity. So x goes to negative infinity. And then it looks like here at my vertical asymptote, see how it's going up forever on both sides? So I can say x is approaching -3 from the negative. And then it's also approaching -3 from the positive side. So x is approaching -3 from the positive. And then it's going to go to positive infinity. So then x is going to go to positive infinity. And so now I can go through and I can say what my y is doing. So as it approaches negative infinity, my y is going towards 0. As it goes to -3, it's going to go to infinity. As it goes to -3 from the positive is also going up forever, so it's going to go to infinity. And then as it approaches 0, as it goes to infinity, it's approaching 0. My brain went like a whoop. So as my x goes to infinity, it's going to approach 0. Now, this one right here, you can go ahead and just leave it as it's written. So it's perfectly okay to leave it as it's written. You could technically simplify the way we draw the end behavior, because if from both the negative and the positive, so from the negative side and the positive side, if they're both approaching the same infinity, so if you notice it says -3 from the negative and then -3 from the positive, they're both approaching infinity, we could technically just say as x approaches -3, y goes to infinity. Now, you're not wrong if you break it up. If you leave it broken up, that's completely okay, because it's a good way to visualize it. But just know you can combine the two. If both from the negative side and the positive side, on both sides, if they approach the same infinity, you can combine it together and just say it's going to the same direction. Because then as a mathematician, as we read this would tell me immediately that it's going to infinity on both sides. Comments or questions on any of these? Okay. Number 6 is just very similar to what we've been doing. So just remember, you have to factor the denominator. Those are your vertical asymptotes. If anything cancels the numerator and the denominator, those are your holes. So I don't think that there's going to be any holes in this one because x is my numerator. There's not going to be any just x's in the denominator. So you're going to have 2 vertical asymptotes. Those are going to be your domain exclusions. Your horizontal asymptote, the degree on the denominator is larger than the top. So it's automatically going to be y equals 0. And then the graph the following, just go ahead and use Desmos to sketch the graph. All right, let's look at some of these cost problems now. Because I'm sure you guys, the graph of number 6 is insane. No. It's not insane. these can get much more insane, let me tell you. Let's just take a look at it though. That's not insane. That's not insane. This can get much more insane. You know, I could say, right? Just adding one more factor in the denominator, and it gets infinitely more complex. Right? And then I could add another factor. And it gets even more complex. Right? So it's the more the more stuff you have in the denominator, the more potential vertical asymptotes you're going to get. And so that's where it's basically the end behavior. You know, it's going in all sorts of directions here. That's funny. All right. Number 7, it says the cost C in dollars to remove P% of the invasive species, the Asymptote fish from Sasquatch Pond, is given by that equation. Find and interpret C of 25 and C of 95. So all C of 25 is the cost to remove 25% of the species of fish. And all you have to do is just plug in 25. And then cost of 95, that's going to be the cost to remove 95% of the fish. And you just plug in 95. So what does the vertical asymptote at x equal 100 mean when in the context of the problem? Well, if we're talking about percentage of the fish, well, if my value P is 100, that's 100% of the fish. So my vertical asymptote tells me that it's essentially, if it's undefined, it's impossible to get rid of 100% of the fish. You can get 99.99999% of the fish, but it's impossible to get rid of 100% of the fish. And it says, what percentage of the fish can you remove for $40,000? So that means that we just have to set up the equation. 40,000 equals and then we have to solve for P. So you just want to get P by itself. And so get P out of the denominator here. So you're going to get 40,000 times 100 minus P equals 1,770P. Distribute that, ... I think you guys can solve a linear equation there. Comments or questions on that? Any questions on the verbiage that I used in explaining that? Because it is a rational equation, so there's some real life context that's involved with the rational equation. So on A, B, or C, any further questions on that one? Cool. All right, number 8. So this is just a recap on all the other things. So it says find the formula for the average cost. So this is just going to be if c of x equals 100x plus 2000, then my average cost is going to be this. Done. If you guys wanted to simplify that, you could just say 100 plus 2000 over x, but this is fine. For part B, it says find and interpret C bar 1 and C bar 100. So that means that for part B, you're just plugging in 1 or 100 into this equation here. It says how many DOPs need to be produced so that the average cost is $200. So that means we have 200 equals 100x plus 2000 over x. You just want to solve for x. So multiply both sides by x. So 200x equals, and then, you know, you want to get x by itself, etc., etc. Dot, dot, dot. Questions on that one before I move on to the next part? I know it blocks. Let me move it. Choo. So this isn't done. Just remember, it's dot, dot, dot. You got to finish that. And then part D, it says find and interpret the behavior as x approaches 0 from the positive. So if we were to look at the graph, right, and we can even pull this up in Desmos. All right, so let's look at this graph. Okay. So it says find and interpret the average cost as it approaches 0 from the positive. So basically, it's kind of like a weird conundrum, because using this hint, C of 0, well, C of 0 is your like startup costs. So if I plugged in 0 into here, I haven't produced any of these devices yet, and it's going to cost me $2,000 to do that. So trying to find the end behavior, or it's asking us, like, what is this idea of this value approaching infinity, trying to find the average cost of producing nothing. It's kind of like one of those like weird, doesn't make very much sense mathematical issues. And so the idea here is we don't necessarily know what the startup cost would be. And so that's why it could be into some potentially some super high astronomical number. Or you could simply just say, yeah, we don't, and I guess that's going to go towards E right here, where it says interpret the behavior of this function as it approaches infinity. So that is just saying, as this value is going towards infinity, right, eventually there's just going to be some level of cost that it's never going to decrease past. So it looks like that number is 100. So as I start producing more and more and more and more and more, I'm never going to be able to reduce the cost of whatever it is that it's going to produce. So these devices, it's always going to cost me $100 per device as I infinitely produce more. So as a repeat for part D, this end behavior gives us an ambiguity to the startup cost. So we don't know what technically our startup cost could possibly be. So that's why, this number approaching infinity means that's a really, really large startup cost. It also means the mathematically speaking, how do you find the average cost of something you've never produced yet? Doesn't really make any sense. You'd have to produce something to be able to find the average cost of it. And then for part E, as my function approaches infinity, so as it's going on forever to infinity, it's going to eventually level out at some sort of cost value. And so that cost value seems to be $100. And that's part of the reason why, even if we're thinking of something like Xboxes or PlayStations, why is it that they cost $300? Why can't they go below $300? And it's literally a graph because of like this. Like, as you produce a million Xboxes, there's just a level threshold that you just cannot go below. It just has to be there. Has to stay at that value. If you go below that value, you lose money. Because there's a cost that you can't make it cheaper than what it is. And so that's where that fixed cost could come in. All right, so that is our lesson. Are there any last questions before we're done here? Great. Well, if there's no other questions, if you come across something, just go ahead and post it in Discord. I will have an announcement probably later today or tomorrow about Alex and what I'm going to kind of do with that. And as it's a good thing, so don't worry about it. So yeah, still trying to figure out how I'm going to outline some of those things. This whole everything transition to online is kind of weird on my end too. So I'm trying to figure out what best works for you guys and your learning and all that different stuff. So just be aware that that's an announcement on that's going to come up. Other than that, we're done here. Thanks, guys. Have a good one. Stay safe, and I'll see you tomorrow.